Okay, welcome back to another exciting KM6 LYW radio video. We talk about amateur radios. We talk about Raspberry Pi stuff here, emphasis on digital modes. And I know we do a lot of Linux stuff on the Raspberry Pi, and not every amateur radio operator is a Linux expert. I get that. If you are a Linux expert, move on. You go on, check out another video. You're excused. You can move on. But if you're not sure about how to copy files or what StreamFlow IO is, how to pipe information between programs, how to get your know your way around the Linux command prompt. We're going to talk about just the basics, just enough stuff to get you by there, and maybe a little more of the Linux philosophy in general. And we're going to do that this time on KM6 LYW radio. See if I can get this. All right, I don't know how long can we do the bumper music thing. So welcome back. I don't know. That was a screwed up version of Leonard Skinner. I apologize to Leonard Skinner for that. All right. So every YouTube video is formulaic, right? You have a little introduction, then you have some bumper music, then you got some content, maybe a resolution. I don't know. I'm trying to follow the formula, guys. Work with me here. Work with me. All right, let me make myself a lot smaller. We got a web browser open here. We have got an amateur radio connected to a Raspberry Pi. We're going to mess with this in our Linux lessons here, and we're just going to cover some real basic Linux topics. It's all going to be all about the Linux command line. I think all of you already know how to use the GUIs on Linux. As you know, the DigiPi here is running the Linux operating system, but there is no GUI. It's all done by using a web browser or your cell phone. But if you want to hack on it, if you want to tweak it, kind of make it your own, you really should learn the Linux command line stuff. So let's start with the Linux file system. This is the DigiPi web interface, and this does all these amateur radio modes. That's a whole nother topic. Check out my other videos for that. But there's a shell button right here. Don't be afraid to click on the shell button. All right. So here is the shell. It's going to open a command prompt. A shell is just another name for a command prompt. I can make this a little bigger, and it's going to ask me to authenticate myself. I'm user Pi. And on all Raspberry Pis, when you first put them together, the password is always Raspberry. And I don't know, I have a gene that doesn't let me type that. I don't know why. All right, so here's our command prompt on our DigiPi, which is a Raspberry Pi running the Linux operating system. All right, so down at the bottom, obviously we see this is our username. It's called Pi, and we are at a host name called DigiPi. And our current working directory, what folder we're in, what folder our command prompt in is tilde, and that means your home. You just have to accept that. And the dollar sign really doesn't mean anything other than, hey, this is a command prompt. So here I am. I can just press return all I want on my command prompt. Does absolutely nothing. There's your first lesson. So I am in let's see, what directory am I in? What folder am I in? We said I was in the home folder, but can we be more specific? So I can type pwd, and that stands for print working directory. And hey, I'm in the /home/pi directory. So what does that mean? So up at the top of the file system, there's the root file system, and under that there's multiple folders. Again, we call them directories. I'm going to call them directories from now on. And so at the root, there's the root file system, and there's folders under that, and then inside each of those folders there can be files or even more folders, and we can keep going down. It's just this gigantic tree of directories. Now I can change directory. That's what the cd command is. I'm going to cd to slash. Now, slash is the name of the root folder. That's the folder that holds all other folders. That's the root directory. So I'm going to do cd slash, and you notice my prompt changed, and it's telling me I'm in the root directory now. Now, if I type print working directory, it simply says slash, okay? And I'm in the top level folder. Now, if I want to see what's in that folder, I just type the ls command. I think that just means list. It's just, if you don't want to type list, you can just type ls, and it's going to list all of the things that are in this folder. Now, there's two types of things that can be in a folder. It can either be a file or another folder, what we're calling directory. And in this case, they're all directories. They usually have different colors associated with them just to help you out. So these are all the directories in the root folder. You only need to know two of these. So the two that you're interested in are etc. That's where application configurations are, and your home directory. All right, that's really it. There's no disk drive letters. So if I have an additional disk drive and I wanted to add it, I could just add it I could graft it into this gigantic hierarchical file system as a new folder. A disk drive would be a folder rather than having drive letters. That's a big difference between Linux and other operating systems. So that is the Linux file system in a nutshell. Don't worry about all of these other folders. The only thing you need to know about is etc and home. Okay, that's the only anything you're going to edit is probably going to be in those two folders. So I'm going to change directory into home. And I'm going to see what's in home. Hey, there's a folder called Pi. Let's cd into Pi. I know it's a folder because it's actually kind of that blue color. There's other ways to tell as well. So now I'm back in my home directory. And I'm going to do an ls in my home directory. There's going to be a load of files in here. Holy cow, there are a bunch. In fact, I don't know if I can make this a little bit bigger or not. Oh man. So you see that the regular files tend to be green and folders tend to be blue. That's just a convention of different Linux operating systems. You can change those colors. For example, a PNG file, sometimes it'll look at the file extension and make it a cool color too. Like a PNG files, it tends to make red. That's a graphic file. And these are all the different files. You don't need to know what any of these mean. You really don't, unless you want to hack on something real specific. So those are all the files in my home directory. All right, so now we have stuff like like I said, everything is a file in the Linux operating system. Even devices are files. In fact, we call those device files. So this radio is actually a file on my Linux desktop. In fact, device files are stored in /dev for device files. It's not too complicated, right? If I do an ls in here, I can see all of the device files. Man, there's a whole mess of them. There's a device for your mouse. There's a device for your monitor. There's a device for your printer. There's a device for your keyboard. Let's look at the device files for my radio. Those are always going to be TTY USB something. And when I put an asterisk on the end here, that means anything that matches that. So I'm going to do ls to list all files that start with TTY USB and end in anything. That's what the asterisk means. We don't have any there. No such file or directory. Remember, everything is either a file or a directory. So that's pretty accurate. All right, so let's do ls tty acm. I happen to know this is how where the radio device files are. I don't know what acm stands for. So let's list, that's what ls is, all files in our dev folder where we're at right now. They start with TTY ACM, and this is case sensitive. Everything's case sensitive in Linux. And hey, there's two things here. There's TTY ACM 0 and TTY ACM 1. So I happen to know that the cat controls, like the changing the volumes and the modes and everything, and power levels on your radio, is all done through the TTY ACM device file. So I can send characters to that file and write to the file, and it'll affect the radio if I know what characters to send it. And likewise, if the radio wants to send information to me or a program, it will also write to that file, and I can read from it, so I can get information. So it's kind of a two-way communication, a two-way portal. That's what a device file is to a device, and that's what we're going to talk to right here. So for example, I can say cat TTY ACM 0, and cat means concatenate all of the characters that come from a file. This could be a regular file or it could be a device file. It can't be a folder, so you can't cat a folder, so to speak. You can do an ls on a folder. So let's cat. That means concatenate. It's an old term. TTY ACM 0, and I'm just going to press enter. Now we're basically listening to the radio and everything that it sends to us. So right now the radio is totally idle. It's on a JS8 call frequency, but watch when I touch the dial here. I can touch the dial now. Watch. See how the cursor moves and we get all these weird characters? That's the radio sending data to the device file and me reading it with the cat command. I know it's a bunch of nonsense. It's a bunch of binary data that doesn't render well on the screen, but we could actually cat TTY ACM 0. And I want to send the output of that to the root folder. And in that root folder, there's a folder called TMP. And in that TMP folder, I want to create a file called output.bin. And bin, it just means it's binary data because we saw that weird garbage that didn't render well. So that means it's not ASCII character, human readable data. So now I'm going to do that. And now when I touch the radio, all of that gibberish that you just saw is actually going out to a file in the root folder, in the temp, in output.bin. And I wiggled this thing here enough. And I'm going to hit Control C to stop that from happening. I'm no longer listening to that device. So let's go into the /temp folder where I put output.bin. If I do an ls output.bin, you'll see it there. There it is. Now I can pull this into a hex editor. I could cat this file. I could cat output.bin, and it'll be just a bunch of garbage like we saw before. Or I can pull it into a hex editor. This isn't really text. I can't pull it into a regular text editor. What I can do is run something called hex edit and look at output.bin. And these are all of the numbers that came from the radio. This is the frequency changes, and it's telling. This is basically the output of me wiggling that dial, output.bin, and that's the end of the file there. So hex edit. I just looked at the contents of the file called output.bin, which is in the slash temp directory on my Linux file system. So that's kind of an introduction to StreamFlow IO. So we can send the output of one thing to the input of another. Programs, you can pipe things together. In fact, I got let's take it a bit further. So we can programs. We got something called this is gonna be. I don't know if this is gonna be big enough. So I can do something like run the command echo, and I'm going to send the characters capital F 1407800. Make sure I'm not on that frequency. And I'm going to pipe the output of the echo command to the input. That's what this pipe symbol is. I'm gonna, so the output of the echo command is going to be the input of the rig control command, which is going to talk to my radio, which is on device file TTYACM0. Remember we talked about that. So I'm going to hit enter here. See what this does. And you'll notice my radio actually changed frequencies. So obviously, if you send a capital F, 140780000, and pipe the output of that command, the echo command, to rig control, which is a program, not a file, and it has options to tell it like, well, yeah, this is an ICOM 705, so kind of reformat it so the ICOM will understand it. And then the radio device file is in the slash dev folder, and the device file itself is called TTYACM0. And that's just an example of StreamFlow IO when or piping output of one command into the input of another command. So that output of echo went to the input of rig control. Yeah, if I use a lowercase f, I just happen to know this. It'll tell me what the frequency is of the radio. Let's set it to, I don't know, 14090. And if I just hit that, it's going to tell me that we are on 14090. So there's just some examples. So you can see how this gets powerful, right? And you can start scripting this stuff. So that is StreamFlow IO. So we covered that Linux is really just a huge hierarchy of files, and a file can be like your resume or it can be an actual device. We talked about two programs that we can run. The output of one program can become the input of another program, and we can do that kind of thing. So that's piping between programs. Now, let's say someone tells you to edit a file. I mean, it's like, oh man, how are we going to edit a file? I don't have Notepad, or I don't know what do Mac people use. How much coffee there left? Um, Let's edit a file. Someone says, hey, edit a file and do something cool. So there's a couple of different editors on Linux, and none of them are really intuitive because they're not GUI editors. They're all text-based. One of them is called Nano. That's real popular with the Linux new users. And another one called VI if you're a little more advanced. And the third one I'm not going to go into called Emacs. I don't care for Emacs myself. That's almost a religious war if people ask you about that. So let's say we want to edit something. So I'm going to just type CD. If you type change directory all by itself, it takes you to your home directory. Kind of cool, huh? That's just a shortcut. Now I'm going to do an ls to see what files are in here. Now right now, this DigiPy, if you can see it here, has, boy, that's hard to read. It's just displaying a cool banner with the radio and the version. So I wrote a program called, I can say nano to pull a program into a file, digibanner.py. You notice how I kind of type real fast at the end there. If you hit the tab key, it'll kind of complete the file name if there's a file that matches that. So that's why it looks like I'm typing so fast. So Nano is the editor. It's a program, and we're going to edit a file called digibanner.py. And this is a Python program that I wrote that writes to that display. It shows what you're seeing right there. And I'm using the page down key. And let's see, what do we got here? We can see inside this file, I'm just using the cursor keys, and I can change stuff in here. There's an image on this radio, if you can see it. It's actually a ICOM 705 on the bottom of that. Let's say I want to change that. I want to change that to a different radio. That's going to be hard. I know that's hard to view. I don't know, maybe I can make this a little bit bigger. Yeah, it's blurry. But see, there's an ICOM 705 down there. Let's change it. And that ICOM 705 is in a file called /home. That's the top directory. And in that directory is another directory called pi. And in that directory, there's a file called radio.png. So let's change that to something else. I'm not gonna change this file. What I'm gonna do is copy another file over the top of radio and change it to a different radio. So I'm gonna hit Control X to exit. You can see at the bottom of the screen here, that's the menu. So Control key and X. And I just exit. I didn't save the file. If you had changed the file and hit Control X, it would prompt you like, "Hey, do you want to save it?" And you'd say, "Yeah, let's save it." All right, so let's look at. I'm going to do an ls of all files that end in PNG. Remember, the asterisk is kind of a wild card. It means everything, and then it ends with PNG. So ls space asterisk PNG, and here's all the PNG files. So remember, we looked at one called radio inside that program that actually writes to that display. And right now it's an ICOM 705. I've got a couple other ones here. This is an ICOM 705 picture, and this is a Yaesu 2980 picture in here. So let's copy the 2980.png file. So CP is the copy command, and then I want to copy that over the top of radio.png. So copy one file to another file. Copy the contents of one and set it to the contents of the second argument there. All right. So I'm going to do that. And now when I run a program, so when you run a program, a lot of times you can't just type the program if it's in your working directory. That it isn't searched by default. That's kind of a security thing. So when I run ls, it's actually the ls command is in where does it? It's in a search path. So if I do which ls, it'll tell me what folder the ls command is in. And this is the which is just for commands. So which ls, so it's bin ls. So what I want to do is type dot slash, and so dot is your current directory where you exist right now. So dot slash. So in the current folder, run a command called digi banner.py, and that's going to rewrite this display. I know it's hard to see. And then we're going to see a different radio on there because we copied the Yaesu radio over the radio.png file. So we copied this file over that file. Now when I run the program, it's going to display something else. Let's see what it says here. It says Digipy. It says just true title. And you can see, I don't know if you can see that. There's a Yaesu radio down there. Um, and so basically we just modified how this program works just by changing one of the files it uses with the copy command. So that's the DigiBanner program that writes to that display. So let's say you want to edit. Let's actually I don't know. Let's go back to the DigiPy. Let's say you don't like this little character up here, this little KM6LYW radio icon. We can change that. Let's go back to our shell. Now, the web page for the DigiPy and most Linux servers is going. I'm going to cd into it. Actually, I'm going to become root first because only root can write to those files. So to become root on a Raspberry Pi, so right now we're just a regular user. Normally we type sudo and then some command and it would run it as a root user and have all your privileges. But what you can do is type, this is kind of a shortcut, sudo su, that means switch user to root and put a dash in there too. So su, and open a new shell, that's what the dash means, to root. And you'll notice my command prompt changed to a pound sign. Now, if you're entering commands at a pound sign, that means you're root. You can destroy the system now. There's nothing you can't do as the root user. So exercise extreme caution when you're root. So I'm going to now that I'm the root user and can do anything I want, including edit that website for the DigiPy, I'm going to cd to the root directory /var. That's a folder, that's a directory. And in the directory of var, there's another one called www, right, for World Wide Web. And in that directory, there's another one called HTML. So cd var www.html. Now I'm going to do an ls in here to see the website. These are all the files that comprise the website of the homepage of the DigiPy, which you're looking at right here. Now, index.html is always the what gets served up by default when the web server serves up a directory. It always looks for index.html. But in this case, I created a header.php file, and I'm going to do nano. You can either use nano or vi. I know nano is easier. You'll probably switch to vi in the long run. So nano header.php. And we can see the contents of every HTML web page, basically. And in here, there is here's a radio PNG file, and so I have another radio.png file in the top level of the web server. So the web server doesn't see the root directory. The web server's root directory is var www.html. That's why I can write it like this. So I can change. So right now the radio.png is currently this little symbol, the KM6LYW microphone symbol. I could use a new logo. I don't know. It's not my favorite. So I can change that to something else if I wanted to. Actually, I'm gonna hit Control X and I'm gonna look to see what my options are. I'm gonna do an ls, and there is a icom705.png file in this directory. So I'm going to say ic705.png. I'm going to memorize that. Now I'm going to do nano header.php, and I'm going to go down where find where it says radio. You guys are following along here, right? Let's get this, make this smaller. I think I selected that, so let me see if I can cut and paste it. Yeah, I can. So ic705.png, this is going to be the image. This is HTML code. Not really code, it's kind of a markup language. And so now I'm going to hit Control X to exit out of here. And it's like, hey, you modified this file. Do you want to save it? Yeah, I do. So I said, file, I say yes, and then file name to write to, it says header.php, and I'm going to hit enter. And it wrote the file. Now remember the cat command? We can actually cat header.php, and it'll just throw the file in front of us. There it is. And we can verify that our change is there. That's towards the end of the file. So now I just actually updated the web page, changed the image that it displays in the upper corner. Now what if I reload this web page, we should see my ICOM 705 radio there. And I'm gonna hit refresh down here. Wait for it. Hey, and there it is. The ICOM 705 is now the image at the top of the DigiPi homepage. So wow, so we've modified a web page just using the Linux command line, using nothing more than the shell on the DigiPi. Of course, you can use PuTTY if you're a Windows user to get a shell on your Raspberry Pi. But in this case, I made it easier for the DigiPi. If you want to open a command prompt, you can just click on the shell link here, which takes you right to this. All right, so let's make sure we got everything covered here. We covered a lot of cool Linux philosophy stuff here today. Um, I am going to exit as the root user because I don't like being the root user all the time. Now we're just the Pi user now. See how it says Pi here? So we're now Pi at a host called DigiPi, and we're back in my home directory. All right, so let me back that out a little bit. We're not going to play with the DigiPi today. I know we're not going to really do cool radio stuff, but we did modify the DigiPi, which is totally cool. Questions and comments down below. Please like and subscribe. We're over 1,000 subscribers now. I can't believe it. This is fantastic. I know this is a little dry stuff, but I think this is just enough Linux to get you going to start thinking about this. And maybe you completely destroy it. You become the root user and you blow away all the top folders. That's okay. On the Raspberry, it's just an SD card. You can always just write to it again and get right back to where you were before. So don't be afraid to experiment on Raspberry Pis. Now on a PC, that's a little different. If you got a whole full-blown computer or server, you got to be a little more careful. But experiment. Make big mistakes. Learn from them. I know I have. And with the Raspberry Pi, remember you're not doing any damage really. If you screw everything up, you can always write that SD card again and get right back where you were. Plug it in, turn it on, and you're right back where you were. So that is Linux in a nutshell. I mean, that is just the beginning. It just gets cooler from there. So none of this would be possible without the patrons. You guys, just amazing. It's still blowing me away. Lots and lots of patrons now. So patreon.com/KM6LYW radio. It's just fantastic. Fu, Brian, Jake, Jason, Dan, Christopher, you're just doing an amazing job, guys, helping out on the mailing list, helping out on Discord. I'll put those links down below too, so you can get really engage with this community. Claude, Jorge, Fallen Yoda. I always like to say that one. If you have a cool Patreon name, I'm probably going to read it. All right, so Fred, W1FRD, all right, cool call sign, I like it. Dusty, John, Ian, Ronald, Alex, hey, VK2JNC, remember we're going global here. We got the Canadian call signs here. Cliff, Motor City Man, Peter, Marco, Steve, BB, Matthew, Jeff, Ryan. Thank you guys. The patrons on Patreon. Again, that's patreon.com/KM6LYW radio. And I really appreciate it, guys. All right, so now you guys are all Linux experts. There's nothing you can't do, especially if you're root. Remember sudo su-root, right? You become root. Thanks for watching this video, and I'll see you next week.